Welcome back again in Cairo Dar. We are going in our journey in mathematics, and again we have to discuss about the calculus. We talked before about the continuity of a function. Now we have to add one more lesson about the continuity. Our lesson will talking about continuity of a function on interval. Continuity of a function on a interval. طيب احنا بندرس هنا الكونتينيوتي واحنا عرفنا ان في كونديشن للكونتينيوتي. طيب what about the interval? Do we have a different way to discuss the continuity about the interval, if it's closed interval or open interval or semi-closed or semi-open? Let's try to know together. First we have a definition. What the definition says? If the function f is defined on the interval A and B. Take care, this is an open interval. Yes, what will happen? We can say that the function f is said to be continuous on A و B اللي هي الأوبن انترفال if it is continuous at every point belongs to this interval. يبقى first case that we are talking about, if we have an open interval A and B, just like that, A and B open interval, and then when we can say that the function f is continuous on this open interval, if it's every point belongs to this interval, مالها every point belongs to this interval, the function must be continuous at each one. This is the first type. Number two, I اللي هي الانترفال بتاعتنا will be like that. A and B, this is closed interval. طيب and f is defined on I. ماشي. امتى ال f بقى is said to be continuous on I if the following conditions are satisfied. ايه هي الكونديشن بقى؟ نمبر 1 if is continuous at or on A and B، يبقى لازم الاول نعمل تشيك ان يكون الفانكشن f دي continuous on the open interval A and B. Second condition must be satisfied that if is continuous where from the right of A that means f of A from the right means A positive must be equals the limit when x tends to A from the right f of x equals f of A. Number 3 f of x or f is continuous from the left of P, that means we can write it like that. F of P minus means from the left equals limit when x tends to P from the left of f of x equals f of P. So we discussed now about two kind of intervals. If our interval is an open interval A and B, so f of x or our function said to be continuous on the open interval if it's continuous at every point on this interval، وده الدرس اللي احنا شرحناه قبل كده. طيب second if we are discuss the continuity about the closed interval the function on closed interval A and B, there is 3 conditions must be satisfied. First, f is continuous at the open interval A and B. Second, f is continuous from the right of A and f of continuous from the left of B. طيب let's have together now some kind of continuous function, some types of continuous functions. ليه الريمارك دي؟ عشان هتوفر علينا بعد كده. Number 1 f of A f of x equals A, this is بنقول عليها constant function, then it will be continuous on R. So firstly, the constant function f of x equals A will be continuous on R. Number 2, f of x equals A0 plus A1 x plus A2 x power 2 plus blah 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 till an x power n. احنا بنسمي دي ايه؟ برافو عليكم، ده polynomial so it will be continuous on R. So أول حاجة the constant function will be continuous on R, the polynomial function will be also continuous on R. Number 3, if we have a function like that, f of x obtained from divided of g of x over h of x, that means we have two functions divided by each other, so it will be, yes, continuous. بس فين بقى؟ on R except set of zeros of الفانكشن اللي في الدينومينيتور اللي هي مين؟ zeros of h of x، وده مهم جدا. طيب لو احنا اتكلمنا دلوقتي على الكيس نمبر 4 اللي هما التريجونومتريك functions، مالهم؟ functions اللي هما الساين والكوزاين والتان مثلا. طيب هنتكلم على الساين والكوزاين. f of x لو equal sin x واختها f of x equals cosine x, that means directly الاتنين continuous on R. طب what about التان؟ لا التان خلي بالكم بس، فاكرين انتوا الساين والكوزاين كانوا بيترسموا كده، اللي هي زي الويف، واحده كده والتانيه كانت بتبقى كده، فدول الدومين بتاعهم كانوا بيبقى R. انما التان كانت رسمتها اللي انتوا خدتوها في اولى ثانوي كانت عامله كده، فما اقدرش اقول عليها ان هي continuous on R، دي special case. طب التان بقى هتبقى عامله ازاي عشان نكتبها؟ التان هتبقى ليها condition. لو انا عندي f of x equals tan x، دي هتبقى continuous فين؟ نفكر كده مع بعضينا. هنقول له هي هتبقى continuous at x not equals pi over 2 plus n pi وال n belongs للz، وده الكونديشن اللي يخلي التان continuous، ان هي continuous بس بشرط الاكس not equals الكونديشن ده. طيب احنا كده خلصنا الريماركس بتاعتنا. Let's go to discuss some kind of function. Discuss what? Discuss the continuity. Example number 1. Discuss the continuity of the function of the following functions. Number 1, f of x equals x squared plus 5x plus 7. What do you think about this function? Yes, it is a polynomial function. As we said about the polynomial function, what will you have? Yes, it's continuous on R. So as we said before in the remarks, if our function in the form of a polynomial function, then it will be continuous on R. It will be continuous on R. Type. Let's have another function. f of x equals x plus 2 over 2x plus 1. This is the division of two functions, g of x and h of x. Let's remember together, we said that if the f of x obtained from divided between two function, then it will be continuous on R except set of zeros of the denominator. So let's try to apply these words here. We will get the denominator, which is 2x plus 1, make it equal 0. So it will be 2x equals 1, then x will be half. ايه اللي احنا عملناه هنا؟ we get the value of x which makes the denominator equal 0. Then we can say f is continuous on R except, yes, this is negative half, take care, يبقى R except negative half. This is the condition of continuity of this function. طيب, discuss the continuity again. If we have f of x equals سريعا بقى 3 minus 2x, this is, yes, this is square root. Then we have to satisfy the condition about the square root, which is said that 3 minus 2x must be greater than or equal 0. So negative 2x greater than or equals negative 3. So x smaller than or equals 3 over 2. That means NLF is continuous on, هنا مش هقول R بقى، هنا هقول ان هي على شكل انترفال اللي هي هتبقى نيجاتيف انفينيتي and 3 over 2، وده بالظبط زي ما كنا بنجيب الدومين قبل كده. طيب another example, f of x equals x minus 1 over square root of 2x minus 1. This is a division, but we have the domain of secondary, we have polynomial in the numerator and square root in denominator. So square root of denominator stronger, so we get 2x minus 1 greater than, yes, greater than, not greater than or equal because it's in denominator, greater than 0. So solve the inequality, it will be 2x greater than 1, so x must be greater than half, there is no equal, so half and infinity, open and open, this is f will be continuous on this interval. Type. We discussed now about the square root. What about the cubic root? F of x equals, this is the cubic root of x plus 1 over 2x minus 5. Take care, we deal with خلي بالك f of x لو انا عندي البروبلم cubic root of x كده. In this case we deal with the cubic root as a polynomial, so it will be continuous on R. ليه continuous on R? Because f of x is defined for every point belongs to R. But here we have a cubic root, so we have R, but we have to remove the zeros of the denominator, which will be 5 over 2. So we can say that f is continuous on A, on the this form on R, except negative 5 over of 2. ايه هي ال 5 over 2? This is zeros of the function in the denominator. اوكي, تعالوا ناخد بقى مسألة كبيرة شوية. هو هيقول لي كده discuss the continuity of the function فين الفانكشن بقى اهي f of x equals first we have 5x minus 2 when x between greater than or equal negative 1 and smaller than or equal 3. Second, x squared minus 4 plus 4 when x included between 3 open and 5 open. And the last, x squared minus 3 when x between 5 and 7. We need to discuss the continuity on this function. First, let's try to draw this function. أنا هرسم كده number line. We have on this number line negative 1 and 3 then we have 5 finally we get 7. طب أنا I can't or I haven't a square above the 7 because 7 is not defined, it's open here. Okay, let's try to calculate the value of each. f of negative 1 f of negative 1 نكتب كده احنا محتاجين f of negative 1 هنعمل substitution هنا هتطلع negative 7. So at negative 1 we will write negative 7. Secondly, we have to get f of 3. f of 3 also we will get substitution in the first one. 5 times 3 equals 15 minus 12 equals 13. So we will write here in front of 3 is this is the value of its function. So we get f of 5 equals, when we can get f of 5 here, 25, 5 power 2 is 25 minus 3 is 22. So right here 22, and we can't or we are not in need to get the value of the function at 7 because as we said before 7 is open here. So let's write between negative 1 and 3 it will be 5x minus 2. This is the form of the function, and here we get x squared plus 4, and for the third part it's x squared minus 3. طيب احنا نقدر نقول ايه؟ اولا احنا نقدر نقول نقسم انترفال. هنقول في الاول ان the interval negative 1 and 3 we will deal with it as an open interval. f of x is continuous. تمام. ليه؟ سريعا كده لانها واخده شكل البولينوميال. احنا بس ما بنكتبلوش بقى في الامتحان انها بولينوميال، احنا بس بنفكر ولادنا هنا ليه هي كونتينوس. ده فيرست. سكند، تعالوا على الانترفال الثانيه الاوبن انترفال. ان the interval 3 and 5 also open, f of x is continuous برضو polynomial. Third, in the interval 5 open and 7 also open, f of x again is continuous. وليه continuous؟ برضو لأنها polynomial. كده we done all our work about the open interval. Let's discuss about the numbers between intervals. We have the first interval اللي هي negative 1 و 3. احنا خلاص عرفنا ان هي negative 1 و 3 open، يبقى مالها دي continuous. يبقى لازم نشوف مين discuss عند النيجاتيف 1 و discuss عند ال 3. طيب فيرست كده هنجيب limit of x tends لنيجاتيف 1 from the right. الفانكشن اسمها f(x) 5x minus 2. It will be 5 times negative 1 minus 2. It will be negative 7. So احنا خدنا بالنا ان هي negative 7 equals f. معنى كده ان f of negative 1 هي limit الفانكشن لما الاكس tends لنيجاتيف 1. يبقى نقدر نقول دلوقتي ان f of x continuous at x equals negative 1. طيب let's talk about the 3. هنقول له كده at x equals 3. احنا عارفين ان f of 3 equals 13. طب عايزين نجيب بقى limit f of x لما ال x tends ل 3 from the left. That will be limit x tends ل 3 from the left 5x minus 2. It will be 5 times 3 minus 2. 5 times 3 equals 15 minus 2 equals 13. That means ان الفانكشن بتاعت ال f of 3 equals 13 equals equals مين؟ equals the limit. يبقى نكتب كده، يبقى therefore f of 3 equals limit of f of x when x tends to 3 equals كله كام؟ equals 13. يبقى therefore f of x or f is continuous at x equals 3. So we get now the limit of x from the left. طيب احنا نسينا حاجة يا مستر، ده في احنا لو بصينا كده هلاقي الفانكشن عند 3 فيها definition from the left from the right. يبقى انا ما اقدرش اجي اقول الجملة دي غير اما اتاكد من حاجة مهمة جدا، ان انا لازم اجيب هنا limit لما ال f of x بس ال x لازم تكون tends ل 3 from the right. يعني انا لو عملت كده ابقى غلط؟ طبعا لازم اتاكد من ده. طب ما تيجي نشوف. هقول كده limit x tends ل 3 positive في x squared plus 4. يبقى 3 squared plus 4 equals 13. ايوه كده 13 equal 13. معنى كده ان الليميت from the left equal limit from the right. يبقى انا اقدر اقول ساعتها ان الليميت exist و equals كام؟ 13. يبقى ناكد على كلامنا ان ال f of x is continuous at x equal كام؟ 3. انما طالما ال 3 عندي ليها definition from the left from the right يبقى لازم اشوف يمين واشوف شمال. يبقى احنا كده اتاكدنا ان ال f of x continuous at negative 1 continuous at 3. Let's talk or discuss the continuity about 5. At x equals 5. نركز بقى وما نغلطش الغلطة المتسرعة. f x at x equals 5 هجيب f of 5 الأول. احنا جايبينها قبل كده اللي هي كانت 22. طيب ال 5 ليها definition يمين و definition شمال؟ ال 5 اهي ليها right definition و left definition. طيب يبقى هنعمل ايه دلوقتي؟ هجيب الاول limit لما ال x tends ل 5 from the left و limit لما ال x tends to 5 from the right. From the left, we substitute in the function x squared plus 4, it will be 25 plus 4 equals 29, and limit when x tends to 5 from the right, we substitute in the form x squared minus 3, it will be 25 minus 3, it will be 22. Take care, my dear, that limit x tends to 5 في النيجاتيف للفانكشن f of x not equals limit f of x when x tends to 5 في البوزيتيف. That means ان limit doesn't exist. يبقى therefore we can say that f is not continuous at x equals 5. طيب totally بقى totally we can say that دلوقتي هي at negative 1 continuous, at x equal 3 continuous, at x equals 5 not continuous، وفي الاخر انا عندي 7 open طبعا ما عملتش discussion عليها. يبقى انا اقدر اقول ان ال f is continuous on the interval اللي هي starting from negative 1 and ending from 7. sorry, negative 1 here is closed and 7 is open except the point 5 that doesn't satisfy the continuity about the function. This problem or this example explain very well or clear very well the meaning of continuity on the interval, because we have to separate or divide the border of the interval to discuss the continuity on it. So we will deal firstly with the interval as an open interval and then discuss the continuity individually at each of the point of the start point of the interval and the end point of the interval. Maybe it continuous on both of them, maybe discontinuous on both of them, maybe continuous on one of them and discontinuous on the other, as we show in our example. And by this example now we can say that we have finished the lesson of the continuity of the calculus, and we have finished now the chapter 1 of calculus. Then we are going to discuss together in the next time the chapter number 2, which will be starting with the differentiability. Assalamu alaikum wa rahmatullahi wa barakatuh.